Hey, how you doing guys? It's Ilya here. I do coding stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it. And this is called all elements in two binary search trees. Given two binary search trees, root 1 and root 2, return a list containing all the integers from both trees sorted in ascending order. Let's look at this example. We got these three right here, 2, 1, and 4, and the second one is root 2, which is 1, 0, and 3. And finally, we return this output, these nodes in ascending order. Right here, that's the same constraints. Each tree has at most 5,000 nodes. Each node's value is between the base minus 10 raised to the power of 5 and the base 10 raised to the power of 5. Go for it. First, we can use a queue data structure. You know, guys, queue means that we add elements to the tail and then we can pull the elements from the head of that queue. And we say integer q1 is equal to new linked list of the type integer. We can copy that real quick. Next we say q2 also new linked list of the type integer, and we need to call the helper method 2 times. The first time we pass root 1 and q1. The second time we pass instead of root 1 we got root 2 and q2. Then we create new array list of the type integer. New, or just let's say result, new array list of the type integer. Finally we return this result, but before we should create a while loop, and we got two conditions. The first one, in the case when the first queue is not empty. The second one, when the q1 is not empty and q2 is not empty. We check in the case when q2 is empty, means that there is at least one element into q1. We say this result dot add q1 dot poll. Otherwise, else if q1 is empty, means that there is at least one element into q2. We say result dot add q2 dot poll. Otherwise means that both q1 and q2 have at least one element each. We say result dot add, and in the case when q1 dot pick the q1's value is less than q2's value, which is um, you know, at the head of that queue, we say q1 dot poll, otherwise q2 dot poll. And yeah, that's it. We just need to implement in order traversal, right? We say private void helper, and right here you pass, you just say arguments. You know, you got a 3 node, and you have a root, and you have 3 node. No, you have not 3 node, you have queue, right? You have queue of the type integer. In the case when the root, the current node, is null, then we return. Otherwise, we call this method recursively. We pass root dot left, we go left, then we pass right here q, also we got q, we pass this q, then you know, we do depth first search, we go left, then we go, you know, upwards, and we go right, and we keep doing that. We say q dot add, or just offer, you know, there is offer method as well. You can say offer root dot value, the value of that root, and we go right when we start backtracking, right? We say root dot right, and we pass this queue. Okay, what do we got? We got these 2 queues, you know, linked lists. We call this method 2 times right here for the first 3 and for the second one, q1 and q2 respectively. Then we create the list, which is the result. Finally we return this result, and we got this condition. In the case when any of these, or just this, you know, conditions, any of these condition is true, means that the q1 is not empty, or just q2 is not empty, we check, we enter this while loop, and we check. In the case when the q2 is empty, then we add the element which is you know, at the head of that q1. We pull that element, we remove that element from the head of that queue. Otherwise, from the second queue, from that second queue, we pull the element. Else, we add the value, which is the smaller one, which is the smaller from the first queue, or just from the second queue. And here means that we do in order traversal. First we go, you know, like there is a tree, we go, okay, let's look at this example. We got, for example, A, then B, then C, and then we got B, C, D, F, whatever. We got these 3 right here, and we can ship that 3 a bit. We have, okay, we have A, B, C, D, F, and let's say F and A, B, C, D, E, F. Okay, so we start at the root, then we go left, right here. We go left, then we got right here, we got null, right? So we return, then we offer this value, we add that value to the tail of that queue, so we add D, right? Then we go right, we also got null, we start backtracking as well, and we are here. Okay, we add B, then we go right here, and again we got null, we start backtracking, and so on. Okay, let's run this code. Accepted. Let's submit. Success. There we go. Okay, I'll show you how to do that iteratively. All you need is remove this part. You need to create stack. You know, stack data structure means that we can push the elements onto the top of the stack, and then we can pop the elements from the top of the stack as well. Okay, so you need stack, and you say 3 node stack new stack, which is 3 node. Then in the case when the root is null, we return. There is nothing to do with that. Otherwise, we create a 3 node, which is current is equal to root. Okay. We create a while loop while current is not equal to null, or stack is not empty, we create another condition. In the case when the current node is not equal to null, we push this current node to the top of the stack, and we say this current node is equal to current dot left. We go left, we do depth first search. Here we say current is equal to stack dot pop. We pop the element from the top of the stack. Next we say this queue dot offer, and we add the value, which is, you know, current dot value, probably, yeah, integer current dot value, the current node's value to that queue, and we update the current to current dot right. We go right, and that's it. So you use stack. In the case when root is null, you return. You create a new node, which is the current, which is equal to root. In the case when any of that condition is true, then we create this, we just enter this, if current is not equal to null, you enter this if condition, and you push, you keep pushing the elements onto the top of the stack. You go left, you're here, then here, then here, right? Then current is equal to null, then you break out of that, Oh, okay, by the way, we got while loop. We got while loop instead of if. Yeah, you keep pushing the elements onto the top of the stack. You go left, 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 then you pop the element, the node, which is current. Yeah, you pop the node from the top of the stack, then you offer the node's value, and you go right, and you keep doing that. That's it. Let's run this code. Accept it. Let's submit. First try. Good. Success. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias, on Instagram, add me on Snapchat. Do your best and forget the rest. I wish you all the best. I'll see you next time. Bye.